Hi, Dirk.
Hi, Martin, I think it is, right?
Right.
Hey.
Hello, good morning.
Let's wait a few minutes more. Okay, I guess we can start in that case. So let me start first with one topic about this working group, because EU group doesn't have so many attendants, and I was wondering, because if you have uh, so low, rate, we might to reconsider this working group itself. And I was wondering if for you, joining Mondays 7 p.m. Central European time is something you can do or not.
So for me, I can do it. Would be okay. I would prefer another work weekday, but I can make Monday work.
See, I don't want to force you at all to join that. I'm just looking for the best solution, because we are just 4 in here, and the main discussion usually takes place in the other meeting.
Yeah, I was at least suspecting something like this because, I mean, the main discussion seems to have been at least last week in the evening meeting. I can make this work.
Yeah, and of course I don't expect that you join every week or so. It's just when you have time. I'm not right now saying that this group doesn't have future. I'm just afraid that it's gonna be terminated if we have so low rate. What about you, Zvonko? What's your thoughts on this?
Yeah. Yeah, I see that in the evenings most of the guys are joining, but Monday evening will not work for me.
I understand. Okay.
If we can push it to another day, then it's fine with me. But Mondays is kind of. I have so many Pacific time and Eastern time meetings that I try to keep at least one day free of Pacific and Eastern time stuff.
Understand. That's okay. Okay, I guess we can start. I put one topic in the common compatibility in the agenda, common compatibility fields, and I'm not sure if you follow the mailing list discussion. We are trying to figure out what are the main fields that we should put in the compatibility specification. My perspective on that is I put everything, all my thoughts in the document I created with Joe. Not sure if you read that as well, but we are mostly concerned about kernel configuration for telco use cases. And Zvonko, for you, everything what is in the document and glibc would work, or do you expect something else to be there as well?
Besides kernel glibc, most of our customers are concerned about. I think Christian Kniep also mentioned that software dependency, especially for the GPU use case, would be CUDA compatibility, so that you're running the correct CUDA versions against the hardware capabilities that you would have on the node versus the container. So besides kernel, glibc, it would be library compatibility between container and host.
I see. Okay. And for you, Patrick, from the Intel perspective, do you have any opinion what should be in there, or?
I think I have a little bit more like just generic thoughts on this. I was like sort of thinking that, yeah, we do have our famous QAT crypto and compression acceleration hardware. So sort of my point of view on this one is that, yes, it's basically kernel and or hardware features that would show up in this some kind of image description that what we need to run this properly. Nothing too horribly specific, I think, or that hasn't been expressed in Intel, at least not to me yet. So when something happens, I'll probably need to go digging a bit more. But my point of view would be to have then, okay, if we need something specific, then that basically is like a kernel feature. And of course, not every hardware can have all the features that we need. So some balance between those. I wasn't actually thinking on the glib host and container compatibility, but that might be a sticky point where one hits one's toes if not taken care of. But basically, I think the rest of the inside the container, that's basically, well, the container's business, and that's why it's there. So
Yep.
then you can have some fancy libraries and whatnot you need. So probably don't need to think about that.
I mean, sometimes in the container might require some specific services running on the host that are cannot run in the container itself. So I thought about this use case, but I'm not sure if there's gonna be a rabbit hole. For instance, because with Joe we think about compatibility also in terms of service quality. So for instance, you have a container that requires, let's say, running OVS on the host, and we are wondering if that makes sense as well to describe such a compatibility issue in the schema. Maybe not, maybe yes, and we don't have strong opinion on that yet, but yeah, sometimes we have such use cases like that. And from your perspective, Dirk, do you have any expectations from this working group?
Yeah, that's a good question. So I think I have 2 points, and I'm still reading up because I missed the initial meetings last week, so I'm still a bit fresh on the knowledge that you already have collected and gained. So I think I'm representing, or I'm participating as SUSE, the distribution company. And I think we have 2 use cases. So one is, I think that was already mentioned, is that we would like to have hardware compatibility. So CPU feature compatibility is somehow specified. So for example, if we build a container that requires a specific, I don't know, Intel or AMD CPU instruction extension to run, that we can somehow specify that, like I don't know, AVX or SSE or those kinds of SEMD and extensions that sometimes software wants to use, and then you can't run it anymore on hardware that is less capable. So that's the one aspect, and I think the second part is I would like to ensure that we define dependencies in the form that they can be fulfilled by enterprise kernels, like Linux kernels that are maybe not having the newest version number or the right version number, but they have the functionality that the container needs anyway. So one thought that I had is whether we would go into the direction of like defining some kind of capabilities or things like that you could actually depend on, and you could have like maybe Boolean operations that you could say it's kernel version greater equals X or kernel with feature X, something like, or feature Y,
Oh, I see.
basically. And then you
So
can say, okay, this is what I need. And there are basically 2 ways to define it, right? So one is the upstream Linus Torvalds kernel version that says, okay, this feature was enabled in kernel version release X. But another version of kernels could also have that feature if it provides a certain capability, which has been well curated or somehow well defined.
I see. So the use case you are describing is very similar to this, what we want to propose with Joe, exactly as you described. And maybe I can share my screen and we can talk about this document and problems with that. Let me see.
I would actually sort of be in favor for the thing to describe what the feature is that you need, because I mean some vendor kernels and LTS kernels, they have backported something. So
Yeah.
So they need their own, like you would understand that this version number applies to this kind of vendor in order to figure out the feature. So maybe it's easier to say that this feature is the one kernel feature we need.
I was discussing this with Joe, and he has a good point that not all, like what he said, because I was skeptical about, putting this the versioning in putting into compatibility the kernel version itself, because as you said, like downstream backport stuff, and we cannot always predict what's going on in there. However, not all stuff or features, kernel features, can be described without kernel version. So yeah, sometimes it might be required. So for example, if you need, I don't know, virtual function and so on, you can just check the kernel command lines, enable this, and load appropriate modules. And then based on that, you can say for any kernel version that this is how you enable that virtual functions can work for you. However, sometimes there are patches or some code changes that enable you some specific features, and you have no way of, I don't know, describing these features over kernel module configuration and so on. I think I might be wrong, but one of these this case could be huge pages, right? Protected huge pages. So yeah, sometimes we might require to have a specific kernel version set. And my opinion on that is okay. It's because there was a good argument in the pull request. I think from Susi colleague that he was saying that we are trying to create some kind of vendor lock in that case. Like for example, you are building a container for specific OS and kernel, let's say rel, and you eliminate this container to run on different hosts if you specify that. For example, for telco use cases, you have a bunch of interests to run this specific container only on specific platform, and you don't test this on other platforms. So you eliminate this compatibility information for other platforms. However, it doesn't mean it will not work there. This kind of problems there that you have to
Yep.
cover all use cases, right?
Yeah, I mean, this is something that I'm super interested, right? So I think containerization should not or should be more compatible, right? So
Yeah.
there might be the need to say for compliancy reasons, I don't know, I have subscription counting and I need to stay in a certain boundary, that there is a way to identify these vendor products so that you are not oversubscribing what you have paid for in some form or fashion. But it should be the exception, right? I think everything should be preferably described using capabilities.
Yeah, I understand. And also my perspective on this, that even if we use image compatibility specification for specific container and it doesn't fully describe, like eliminate some hosts on which those hosts the container can run, it's still okay. I mean, it's still okay because the compatibility can be updated later if somebody finds out that it can work there. But right now we are trying to figure out, yeah.
But this metadata is part of the container config, right? So
We didn't decide yet. We didn't decide
okay.
yet if it should be artifact or it should be part of the container. My personal thoughts on that is that the the hard requirements like platform and or maybe CPU features and so on, that stuff that is not easily replaceable, has to be part of the container config, the image spec, and stuff like kernel configuration that is, or OS settings or runtime kernel configuration that is can be fine-tuned or changed, should be a soft requirement and live inside an artifact. That's my personal thought on that. That I wouldn't like to, because for hard requirements for me, it should be part of image selection. So for example, if I have set of images built, I see, okay, this is the specific architecture of the CPU architecture or CPU features, and based on that, I may make image selection. However, if we put everything inside, like, I don't know, kernel configuration, kernel modules, and we include this in the image selection, we easily can get a really big mess, because we would end up with multiple image builds, and it would be crazy in my opinion. We should, I think, put some boundary between what we want to have in the image selections, what are the hard requirements, and soft requirements that operating system can fine tune to meet the expectations.
Yeah, that's an interesting idea. So kind of like compatibility profiles or something like that.
Yeah, something like that. Exactly. So yeah, this has to be also discussed, with the OCI maintainers, as we will see. But also there was, sorry, go ahead, Sonko.
I didn't want to interrupt. Finish, please.
So there was also interesting idea from Vanessa with this Wild West, that, for example, we create some kind of maybe some specification schema, how to put like how to structure the specification, but values are coming from users and tools are coming also from users, in as she called that kind of Wild West, right? And it will be group's responsibility to create tools and put values that fulfill their use cases. However, I'm a little bit afraid of that because we came up with this group to build some kind of standard and not to bring another Wild West to container world. But yeah, not sure if you read that. Maybe you have some opinions on that as well.
So I haven't read it.
Yeah, so
I think I didn't quite get the point. So I mean,
because
it's fundamentally we do need to create a standard for this, right? Or
right.
sorry, I get distracted.
Yeah, I'm not sure if I got her idea correctly, but I think it was like that. That we basically create some schema, and inside the schema you can put any key and values that you like to have, and validate with your own tools and your own libraries and so on. I'm not sure if I got that correctly. However, if that's the case,
Okay. So we have basically one indirection more, so that we have basically a domain language or domain schema
yes,
that you can write.
yeah, it would work like annotations today, right? Because HPC folks, they are putting into container into annotations of the container some the requirements like MPI library version and CPU stuff and so on. So they are using annotations for their use cases, and they came up with some well-known labels and so on. So I think her idea is to build something similar that specific groups like telecommunication, HPC, and other groups, they can build their own kind of known fields and their own tools that they can validate against. But yeah, with that, my problem is that we have I would like to from this group to have well-known fields and well-known standard. So yeah, I
Yeah, I
think
mean
we are,
this could lead to having multiple different implementations of this description language.
yes,
And
yes,
while I see the flexibility gained by that, I'm also very afraid of the complexity. So I don't see a good reason for allowing this level of freedom.
yeah. I mean, as a user that comes from I don't know, image author, I would like to describe my own compatibility, and I see that there is nothing well defined, and I have to come up with some set of maybe tools
Yeah.
or my own language. I would be a little bit disappointed in that.
So I agree, extensibility should be a goal. Right? So I think whatever we come up with should be extensible for use cases that we haven't considered or that are so obscure or domain specific that they maybe shouldn't be standardized or can't be standardized because they work around some problem of real life. And we don't want to standardize on real life problems, but we want to make them go away. But so some form of extensibility is, I think, needed. I agree with that.
Yeah. By the way, sorry, Vanessa, I misunderstood you, but we can clarify that on the next meeting. Anyway, so yeah, right now we are trying to determine what would be the best way, how to do this. As I described you the idea of having hard and soft requirements. So I'm not sure what others thinks about that on the other group. I guess I will find out today at 7 p.m. And yeah, basically this is where we stand. And any comments? Maybe you have some kind of idea how this compatibility should look like. I mean, from the language point of view. I can maybe share my screen and show you what we came up with, Joe, so far.
Yep, please do. Okay, that's the document. Okay, I started reading that.
Yes, that's the document. So as you can see, that our perspective on that is to just describe minimal critical requirements and also meet performance criteria. So it's not only about this that container can run on a specific host, but it also has to meet with performance criteria. So some sort of quality of service. And we described here some perspectives from the user environment application perspective, how this would influence the whole ecosystem. And we came up with fields that we have to think of. So from the hardware point of view, we have model, features, and PCI USB devices. There should be class, vendor, device ID. The same for USB. And then this kernel version is discussable, but from our point of view, I'm convinced by Joe that we really need that. As you also, Dirk, described that you would like to have this as well. And then we have kernel configuration, boot args, module with parameters, because some specific modules enable some features over parameters, so we need to have this as well. And then kernel runtime configuration, like process and sysclass and capabilities. We are not sure about storage device type if we need to provide this kind of information for container about if storage is a block storage or some kind of file system and so on. Also, we didn't also discuss about user space services. This can be a really rabbit hole. I'm afraid with services that over container, you describe some indirect requirements. Like for example, if you would require OVS, you would have to specify that you require kernel module OVS and then over that some specific services. So it's kind of not ideal that in the compatibility we would describe something which is not directly required by the container to work. But yeah, this has to be discussed. It's just difficult.
So with that user space, does it mean that we need some other other things running in a cluster so that this particular container can start to function?
Yeah, I mean, we had an example of OVS in here that for container requires, for example, OVS and to meet some kind of quality of service. But if you start describing over container OVS requirements, it's very wrong. I mean,
Yeah, but I was thinking, isn't that like when you deploy the service, you actually have to ensure that you have deployed everything, or everything's going to be deployed in one way or another that
yeah,
the whole thing needs. So isn't that sort of a known problem and addressed problem already? I mean, you can't probably run Elasticsearch just like snapping your fingers. You actually need a bunch of other system and support and utilities running somewhere else to do that.
yeah, but sometimes some containers might require a specific configuration of OVS, like because this example of 6-win virtual service router, it has very specific configuration, requires specific configuration for the host with I don't know random configuration to be have specific values like I don't know max user instances, max user watches, and so on. And over containers, if we want to describe that as well for services, how service should be configured, in that case OVS. But there are so many possibilities that different containers might require different configurations and so on, that seems to be wrong to describe that. And
That's a big rabbit hole, yes.
yes, exactly. So maybe we should start with something simple and see how this goes. Yeah.
Hey, how about what you had also the storage, or actually touch devices, the storage device type. Does it really matter the type? Is it more about that what you expect as bandwidth or capability, or well, capability you can say that okay, you need this big, so yeah, you can put it anywhere in any small spaces. But if you need some, do you need to measure some instead have quality of service kind of thing instead of directly device type for a storage device?
That's a good question. I mean, personally, I didn't find any example right now that we will need to specify this kind of information. However, with Joe, we were supposed to find out if in telco platform any container requires such information. I think Joe found out some containers that were requiring specific device type and storage, but
That sounds a bit problematic to me. I think what somebody might be after here is that you can guarantee some kind of quality of service parameters like bandwidth,
yeah.
or capacity, or I don't know, delay.
So
Yeah, the same goes a bit. You had the USB and PCI devices there. I understand if you have a very, very specific PCI device, where did that go? That you need that one, but
this is for example, use case for scientific scales or something like that. Some similar thing that
yes,
I had a project where I was working with some scale vendor, and we required in the container required a specific device ID, specific class and vendor and device ID that it only could work with. So I think sometimes it makes to put that. And if you think about, for example, GPU pass-through, you would like to specify class and vendor for the maybe even device ID that container requires. I don't know. Maybe device ID is too much, but class and vendor could make sense to me. Uh, what do you think, Zvonko? Would you like to see some kind of stuff like that for your use cases, where you specify the specific hardware like class, vendor, and so on?
This wouldn't be enough. If I'm thinking about virtualization of GPU, be it per MIC device or vGPU, you would have always the very same vendor ID, class ID, and device ID. So on top of it, you would have the virtualized devices like MIC slices or vGPU types.
But
go on.
That would be for virtualized GPU, right? But if you want to pass through some specific devices, and yeah, I'm not sure about that.
So if you're talking PF, yes, but if you're talking VF, no.
Yeah, I'm talking about PF right now.
Yeah, right.
Because based on that, you have to load appropriate modules. So I imagine like that. I have a class, doesn't matter the class right now, but vendor ID. If it's Intel or if it's NVIDIA, we need to put specific kernel modules, I think, right? Or not. Maybe network card would be a better idea because if it's Intel or if it's, that was Mellanox, I think, you have a different, I don't have this example in here, but you'd have a different kernel modules. So based on the hardware PCI, you have to somehow distinguish which kernel modules you have to run.
Okay, I'm just trying to get my head around that, because if you're talking about pass-through PFs and stuff like that, so we are talking about virtualization. So, and the only use case where I see that it's can fit is KubeVirt or Kata containers. So in the bare metal or traditional containers, how do you see that PFs fit into the image compatibility? Because you mentioned pass-through, so you don't need to do any pass-through with containers.
Right. So that's a good point. Mostly I was thinking about virtualization, how to pass physical or virtual GPUs into KubeVirt, as you said, or Kata containers.
But then again, on the VM level, you have the freedom to run any kernel and any guest OS. So how is this going to help? Oh, well, let me just think. Yeah, it could help because if you're running, okay, no, it makes sense. Yeah.
Okay. Yeah, for bare metal use cases, maybe I should mention here that doesn't make.
Maybe we should, have distinction between, the traditional containers and virtualized environments.
Yeah.
Like Kata, KubeVirt, or other virtualization.
That makes sense.
Sandbox environments for containers. Because I think this will confuse people if you're talking about pass-through PFs and then containers.
Yeah, you're right. You're right about that. Okay, that's something to clarify in the document later.
Yeah, actually, I was a little bit. Well, I need to wrap my head around this. You said, well, you had a good example of like an Intel network card, but the question that I was again trying to spin off here is that what exactly is it in that particular Intel networking card, let's put it this way, that you are after? I mean, is there something that, since you will need to have a kernel driver anyway for whatever hardware you are trying to use, so is that, again, does it fall back basically on that, okay, you want to have this driver, particular kernel driver, please, because otherwise, I don't know what would happen.
Yeah,
Yeah, use DPDK. Yeah, great.
Yeah, DPDK case, and for example, if you want to enable SRIOV for Intel card, you will do it differently than for Mellanox. So you are using, I think, IGB. That was there. You have a parameter to enable SRIOV.
Yeah, but I mean, if you are after some particular feature, wouldn't that, like the feature, wouldn't that cause a lot of things to happen? Some would be a kernel parameter that needs to be either there at boot, or when you have to load up. Of course, you have to load a specific module. Maybe, I don't know.
Yeah. Yes. Exactly.
So I was just wondering. I'm just trying to sort of figure out the landscape a bit here. That how much of this is that this is a sort of a more abstract feature, saying that you have that something, and when you sort of if you claim that yes, you have this compatibility, that's totally fine in the host kernel somewhere, but that means that then actually kernel module had to have these parameters and had to be inserted, and something else needed to be happen, and your kernel had to have this and that thing in addition enabled. But I mean, usually that is because, I mean, if you want to use a specific feature of a networking card is in the simplest case, then you have to have a bunch of other features also already anyway enabled.
Yes, exactly. So, for example, let me show you, because
just so that we don't like over specify or micromanage the details here. I'm a bit wondering where the line in this direction goes.
So all of those are just minimal requirements that are required by containers. So for example, with this 6-wind, the must is most of that what is described here. So from the kernel configuration, this has to be enabled. You have to have these capabilities. Those are exceptions in here based on the where you run, the same as with that, and you have to have loaded specific kernel modules and adjust runtime configuration to this kind of values. So basically, you describe what is really crucial for the container, that it has the specific configuration in terms of kernel boot args, configuration capabilities, modules, runtime configuration, and so on. And we basically came up with this that maybe will clarify how we thought to work with that. We had a tool that, for example, we came up with this language. That is just a prototype, maybe not so useful, but it was to show how it could work. So let's say you have some GPU pass-through configuration, and you describe here the minimal requirements, and later we basically over scanners check if this specific configuration is there. So for example, if you have a kernel command line, you check if the command line contain this kind of value and so on. So yeah, does this answer your question, or should I rephrase that? Not sure if I got you.
Yeah, well, that's probably what I'm like trying to figure out, that how do we go from something that is decently simple to actually take in use and require, then we have to pop into some kind of a formal description of how this is being done.
So basically, how this has been created is we took whatever is required in the user guide, because there is, if you want to run 6-win router on the host, there are specific kernel configuration expected capabilities and so on. We put this into requirements, and we would later translate this to some kind of language. So for example, if you would have 6-win kernel configuration, you would put this in here, and there's some scanner is validating if this configuration exists under boot config and so on, and it tells you the tool if it's compatible or not. And what should be put in there would be up to the image author, if it makes sense or not. But image authors should remember that they have to specify in the image compatibility the most minimal and crucial requirements. We don't want to, put some kind of nice to have configuration, or if that makes sense.
So if we are concentrating a lot on the kernel, and since we all know the kernel has no stable ABI, how are we dealing with ABI changes? Because especially now that you showed VFIO, so the very next step of VFIO is VFIO PCI Core with vendor enabled VFIO PCI plugins. So how we are dealing with that if we have like hard coded like VFIO PCI and the kernel changes, and now it's called VFIO PCI Core plus some vendor NVIDIA MDEV or NVIDIA VFIO stuff. How we are dealing with that?
If you do that, you could set to specific kernel ranges to track the API changes. I'm not sure if we have a better way of that. At least I didn't think of. But over the kernel range. However, when you specify kernel range, we have another problem, because you have to repeat configuration for multiple downstream.
Every major distribution, yeah.
So there was just another idea how to, for example, in easy way, repeat configuration for other kernels. Like there was, let me open code share.
Question aside, as long as you're loading code share. So we are only concentrating on container images. Anyone interested in OCI artifact compatibility? Because more and more users are using artifacts to store specific items that they need for running inside of a cluster. So we are currently only looking into the image spec, right?
Right.
Okay.
I mean, if I understood you correctly, you would like to have compatibility for artifacts itself, right?
Exactly.
I see. Yeah, we didn't think of artifacts at all.
Yeah, maybe as a side quest. So the use case is following. So for Kata or confidential containers, we are shipping the kernel, the guest OS, and some other items that are needed to run the VM as OCI artifacts. And so I would like to have a compatibility as well. So let's say if you're running on an AMD SMP system, I don't want to pull artifacts that are for Intel TDX or for ARM CCA, because they're essentially architecturally independent. You can run your VM on any architecture. What you're actually running in the VM, it's independent of them. So I would also have to have a compatibility on the OCI artifact as well. But let's keep this as a side note or a submarine project.
Okay, we can get back for sure into that once we establish some kind of agreement for the image spec, I think. But for sure, it's interesting use case you have. So if I understood you correctly, so in the confidential, let's say, containers, you have an some artifacts that you want to pull based on the compatibility defined for that, right?
Exactly.
Let me make a note of
because currently it's not everything is upstream, so you have distinct artifacts for each of the TEs, be it SMP, TDX, CCA, or any other. But sooner or later, everything will be upstream, so you will have one host kernel and one guest kernel, and you want to check if this guest kernel has all the needed pieces to run your, let's say, SMP specific container or TDX specific container, because each of those technologies would have different features like a VTPM or sealed secrets or whatever else that may not be available on other platforms. So you want to have the correct artifacts pulled in based on the container it's going to be run. And this also fits into the PCI vendor device ID you mentioned before, because some solution will only work with specific hardware. So yeah, this could be really worthwhile. Okay.
What is just another argument why image compatibility should be an artifact in that case, because you could refer to over subject to image and maybe an artifact. That at least makes sense to me in that case. Zvoko, could I ask you to add a note of that into notes? I send a link to the meeting. That would be the best if you, that I don't want to leave something if I misunderstood or something, but I think
Sure.
Thanks.
Wouldn't like the confidential containers, wouldn't that be a really good example of once everything's upstream, is that we need to figure out somehow that you could express that, okay, we need confidential containers, but I mean, now AMD could serve them, or Intel could serve them, or I don't know who else could serve them. But isn't that like one good prime example of that you can have multiple very differing implementations even on the hardware level to achieve the exact same goal? And in that case, would we need to just stare at the generic capability that is defined to then contain X, Y, and Z on this platform and some other variables on the other one, but the end result should be the same. I mean, if of course the features by the secure confidential containers that they need, that they can be served from both platforms. Otherwise, okay, the other one loses that don't have the features, of course. But was like just thinking that how do we specify that one so that somebody actually can be happy and just take it and use it and run with it and have confidential containers no matter which vendor of the CPU vendor there is below.
But that's a good question, how we could achieve that.
Because well, I mean, if I look at the thing that I'm so happy with the compatibility when I boot Linux, or last time I booted, and when it sort of started to explain to me all the options that it tried for this RAID configuration and selected the fastest one. I mean, that's the sort of the opposite end when everything is pretty much there and standardized. It could actually go pick some kind of set of commands that where it was running fastest, and figured out that, okay, AVX something wasn't actually supported, so can't use those algorithms, and still it runs totally fine. But I think that's a bit of almost a reverse problem for what we have been talking so far.
Yeah, I guess if I understand this correctly, that maybe we are not thinking that much so far about this kind of variance, if I understood you correctly. But yeah, we didn't think over this through like that yet. But because if I understood you correctly, let me rephrase what you said. So basically, you're looking for a way to specify in maybe one schema for one image compatibility that bunch of different containers with different requirements can run based on this, if it's confidential computing or not.
Yeah, exactly. That for confidential computing we would need I mean, some a set of like, I don't know, meta labels saying that these are the features that we want, and the feature would be like defined so that everybody can understand what this means. And then, of course, there could be many radical, very varying implementations of how to achieve that goal. But that will be totally fine, because in the end, when somebody makes an image, says that, hey, I need confidential computing, I need it to be able to do exactly these things, seal itself off and be very confidential and run fine and whatnot. And it needs to have these capabilities, basically, that, I don't know, just inventing now here from pulling out from my left sleeve, like verifiability and then some other authentication thingies or whatever. But then the specification itself, how to dig through that, which of the hosts or things are the ones that can, where this actually can be compatible, they could be very different. I mean, I was just thinking like, okay, Intel, of course, but AMD, once that's in the upstream kernel and it can work. So
it's kind of complex use case, I would say, right now. Because I get your point, but so far we are just focusing mostly on this what. So this minimal requirements, we didn't think about some kind of variant you were saying in terms of what works the best for specific use case. Basically, what we thought right now is just to specify that would be the story, that image author is creating an image, some, I don't know, maybe validation center referring to telco platform or whatever will run this and fine tune for specific platform the configuration and put into image compatibility. And maybe to some extent it would cover what you are saying, but yeah, I'm not sure, to be honest.
I think the level of details is a bit like, I mean, if you can say that, yeah, you need a genuine Intel, yes, sure. If you have an x86 like machine code image, yes, sure, you need that one, or something that actually can emulate it. Why not? So that would be great. I mean, some, I don't know, Apple device could say that, yeah, I can run this genuine Intel, no problems for me, and it could be even fast. So that would be totally okay. I mean, in my books for this kind of thing.
So right now, just maybe it will answer as well your question and your concerns to some point, because we are talking about already. We are thinking about how to cover different kernel versions and so on in ABI, and how to do it the best way when including different variants, if it's Intel or AMD CPU and so on. So I hope you can see this. Let me change to JSON. Yeah, so basically, session expired again. Sign up. Do you know any? Oh, it's so annoying. But basically,
So
what
question.
Yeah, go ahead.
Yeah, just thinking about all this kernel stuff that we're doing here. If we haven't enabled it in the BIOS, all the kernel settings are in vain. So how we are going to check that? Are we thinking of some Redfish host interface to check if the BIOS settings are correct?
We thought about SMBIOS DMI decode, but it will not probably return all informations and so on.
No, it will not.
Yeah, so we were even thinking if we should do that or not, and if we
because it would be a false positive if you're saying, okay, I don't know if it's so. We had one use case where we had said like enable IOMMU on a Supermicro.
Yeah.
And if you do not explicitly set IOMMU enabled in a supermicro, IOMMU will not be enabled.
Yes.
So it's not only like checking for the config, but you may also need to parse the message, or you need to check if the BIOS has enabled it. And coming back to the confidential container stuff, for SMP, it's like 5 or 6 BIOS settings that you need to enable. On TDX is similar. So how we are going to make sure that what we are checking in the kernel, it's really enabled?
So, for instance, yeah, this is a good question because I'm not sure, but if you, for example, don't have enabled in the virtualization and you load specific kernel modules, you would have to parse some messages from the kernel module of those modules, right?
Yeah.
That's a pity. I'm not sure, to be honest. I don't have answer for that. We didn't think of that yet. How to do it the best
and
way.
even if you enable the IOMMU, for example, on some AMD CPUs, to have ACS enabled for PCI Express, you need to enable a complete different BIOS setting, which is advanced error reporting, PCI advanced error reporting, to enable ACS, which is completely counterintuitive. So I'm just worried that what we are parsing or checking in the kernel may not be enabled on the host platform via BIOS.
Yeah, that's a valid point. That's a valid point. We will have to figure out how to do it the best way, or agree on some compromise. Like we will have to find out how to do it.
Yeah,
in
so I
that
think
case.
before we start modeling BIOS settings or not settings, I strongly suggest that we should go into some form of capability mapping, where we say, okay, the host has a certain capability, and how to obtain that capability, whether certain 17 settings in the BIOS are needed or the CPU needs to be upgraded or whatever, is a bit beyond the scope of the description. But the host has this capability, and a container can like require a specific capability. And I think how exactly that is being provided is then an implementation that we need to figure out potentially with the container runtime or related groups.
Yeah, actually, that's basically what I was trying to chase after. I mean, when the host kernel is claiming something, then I mean, maybe it's not this specification's problem to figure that it's actually doing what it's or can do what it's claiming. So I think when you sort of boot up a kernel and then start to explain to the world that what you can and cannot do, then that's maybe if we cut that out of this specification, then we keep our sanity at least to some degree, because if you actually have to go through 17 BIOS settings and then the BIOS is updated and now you have 18 and where to change anyway the name of them or meaning of them or something, but you need to enable them anyway, then this never ends actually, because you get a new BIOS version, you get the same like you get a new kernel version. Now you have a bunch of new config options to think about, and that will never end. So maybe if we draw the line saying that okay, when the node boots up and starts sort of attaching itself to this kind of a framework, and then says that yeah, I have this PF and confidential computing and whatnot, then actually it knows what it's doing and it has its BIOS enabled. If nothing else, then somebody who actually sort of kickstarts the kernel on a node somewhere better than have a test program in the worst case that, okay, if I'm asked to provide this capability, can I actually do it? Yes, no, okay, I can't do it, and then raise an error and scream out in the logs that, hey, now something's wrong. I should be able to do this, but I can't. Please, somebody check what's wrong. So I don't know if we cut sort of the thinking about there and say that we have these kind of things, that yes, they are enabled BIOS and kernel module is there and loaded and all. Then at least this is less complicated, but I'm not sure if we shoot ourselves in the foot with the capabilities that we can express after that.
My perspective on that is just we should start. It doesn't have to be perfect first. I'm sure the first version of the specification would be like maybe sometimes false positive, as Yusmonko described, and over iterations we could improve that, but we have to define something that is flexible enough to extend and we don't go into some kind of like blind corner or so. So yeah, basically we are out of time here, so thank you for discussing that stuff with me, and if you have any concerns, please also use mailing list to join the discussions and so on. I think we can continue the next Monday, and I will also raise some concerns on the meeting today with other group what we discuss here today.
So we have to say morning hour, European morning hour then on next Monday?
Yes, still we have morning
Okay.
hours.
Awesome.
Yeah, till we.
See you there. Bye-bye.
Okay.
Okay.
See you in any
Bye.
meeting. Bye bye.
Thanks. Take care. Bye bye.